Assalamualaikum and hi, my name is Muhammad Ali Arif bin Abdul Rahman from Group 6, and today we will present about our project structure analysis. For the background of the project, Medford Rail Bridge with a length of 40 meters and a height of 5 meters is the bridge that we choose for this project. It is located in Chicago, Milwaukee, St. Paul and Pacific Railway. The Minnesota Central Railway began building an 82-mile railway between Owatonna, Minnesota and St. Paul in 1864. The road was completed to Austin, Minnesota the following year. On this road, this huge pony truss bridge is the only crossing of the Straight River, as opposed to 9 structures on a similar path. This large-scale bridge, built in 1929, replaced a lighter weight structure. This span was most likely transferred to a different place. The bridge is currently made up of a huge 8-panel reverted Warren pony truss. The bridge is supported by concrete substructures, and the goal of this study is to determine the bridge determinacy and truss deflection. Overall, the bridge is in a decent shape, and because of its recent design, the author considers this bridge to be locally notable. So for our problem statement, if manually computing the member forces using an alternative approach, there may be errors that go undetected, resulting in erroneous results. Human mistake as well as incorrect reading and citation may have resulted in the error. For this project, students are asked to compute the internal force, visual force and deflection of a truss construction using an alternate approach and software called LinPro. So the result of these two ways will be compared, and the comparison will reveal if the students' calculation were different. When the computation is done manually, errors in the analysis are more likely to occur owing to human error or negligence. To produce accurate calculation using LinPro software, accuracy is required in the layout and the design of truss. The load value entered should be in accordance with the design specification. For the objective of project, the first one is to practice and apply the structural analysis knowledge, such as alternative method to calculate the member forces. Next, to practice and apply the structural analysis knowledge, such as the function of trusses and calculate the truss member forces. And last but not least, to create an analysis and comparison of the manual calculation and the result of the calculation performed using the software named LinPro.
Hi, my name is Chong Seng. Now I want to present the methodology of this project. First and foremost, we need to determine the stability and determinacy of the bridge structure. The second step is to calculate the reaction force on the pin and roller support. The third process is to calculate the real force, visual force by using alternative method. The fourth step is to put 1 kilonewton force on the bridge structure to determine the deflection of the bridge structure. The last step is to compare the manual calculation result with LinPro software to determine the differences and percentage error.
My name is Kevin Chai Chi-Sian. I will be presenting calculation part 1. So this is the original truss bridge that we choose named Medford Rail Bridge. We added pin support at A and roller support at I. Each length of the section is 10 meter and the length of subsection is 5 meter, and the total length is 40 meter. The height is 5 meter. There are total number of 29 of the members and total number of 16 of the joints. The serial size of I-beam that we use is 610 mm times 178 mm times 92 mm, and the area of the section is 117 cm square. Then we substitute 16, 29 and 3 into the formula m plus r equal to 2j, and we get 32 equal to 32. From the calculation, the structure is statically determinate.
Next, I want to present the calculation of reaction force and real force. Before that, we need to determine the truss weight in each joint of the bridge. In this project, we'll assume one member of truss weight is equal to 0.904 kN. For the truss weight of outdoor joint, from joint P to joint J, is equal to 0.904 kN times 6 member divided by 7 joint is equal to 0.775 kN. For the truss weight of side joint, which joint A and joint I is equal to 0.904 kN times n member divided by 2 joint plus 0.904 kN, which is the truss weight of AP or JI, and we get the answer is 4.52 kN. For the joint with 3 members of truss weight, like joint C, joint E and joint G, it's very simple. It's equal to 0.904 kN times 3, and we get the answer is 2.712 kN. Next, we need to calculate the reaction force on pin and roller support. We assume crosswise is positive, MA equal to 0, and we get the answer BI is equal to 13.11 kilonewton and the force is acting outward. Then we assume outward is positive, MY equal to 0, and we get the answer vertical force VA is equal to 13.11 kilonewton and the force is acting outward. Then we use the alternative method to equivalent all the member forces of the bridge. That's all from me. Thank you.
My name is Yontipo and I will present calculations reactions with applying 1 unit load. First step is apply 1 unit load at point E. Next, assume clockwise moment and outward force is positive. Then, calculate reaction force and the IY and AY is 0.5 kN. After that, use altimeter method calculate and equilibrium all member force. This is the data of the structural design bridge. We assume the Young modulus is 200 GPa, area is 0.0117 meter square. Then use the formula with sum FUL divided by area times Young modulus to calculate the diffractions, and the answer is 7.132 power negative 7 meter with assumed downward force. Next, this is a real force with analysis by software LinPro. This is a reaction force also calculated by LinPro with 13.11 kN at each support. This is internal force member diagram also analysis by LinPro. This is the data of comparisons internal force member between manual calculations and software LinPro. The diffractions between both calculations is around 0.004 kN to 0.14 kN. The percentage error was around 0.13 to 0.16%. The formula to calculate percentage error is exact minus approximate divided by exact times 100%. Next, this is the diffraction calculations by LinPro. This is the data comparisons of calculation diffractions between manual and software LinPro. The software of manual calculation is 7.13 power negative 7. However, LinPro's analysis result is 8.53 power negative 7 meter. The conversion result diffractions between manual and LinPro software is 0.14 power negative 7 meter. The percentage error was 16.41%.
Selamat sejahtera, my name is Gordon Changyumping. I will explain about the discussion, structural integrity, conclusion and recommendation part of our group's bridge project. First of all, our bridge has 29 members and 16 joints, and by using the M plus R equals 2J formula, we note that the structure is statically determinate and stable. After designing the bridge, we calculated the reaction forces by using equation of equilibrium, and we obtained the forces AX equals to 0, AY equals to 13.11 kilonewtons, and IY equals to 13.11 kilonewtons also. Next, by using virtual work method, we obtained a deflection of 7.13 times 10 to the power of negative 7 meter via manual calculation, whereas LinPro provides an answer of 8.53 times 10 to the power of negative 7 meter, which ultimately gives us a percentage error of 16.41%. Overall, the design truss is safe and is able to transfer load equally. Next is the structural integrity. When designing our bridge, we knew that the structural integrity is important for its design as it concerns its safety. It is crucial in avoiding loss of lives and minimizing economic loss. Structural integrity can be achieved by utilizing several aspects, such as fail-safe design, safe life design, damage-tolerant design, and controlled failure design. Lastly is the conclusion recommendation. To conclude our project, we learned that the function of truss and how it distributes load evenly to form a stable and strong structure. Safety considerations are important to prevent failure of structure from happening. As for recommendation, we recommend the use of software application as it provides a lot of information to help optimizing and engineering models. That's all from me, thank you.